Okay, so area under the graph was what we were working on. So we learned that if your function is a continuous function and it's positive on a given interval, it defines a region under its graph, or region on the interval AB below. Oh, did you bring my hot chocolate there? No, you didn't bring anything. See? Okay, I remember that even more now. So AB area under this, we did few steps of work. One was we started dividing the interval into subintervals. So step one, divide AB into n equal subintervals. Well, then we fix the notation for the length of each one of those subintervals. Well, we know that the total length is b minus a. We divide it by n so that we get n equal subintervals. And then we index the endpoints, ith subinterval. We denote it by xi minus 1 to xi. And remember that a formula for xi was that I'm starting from a. If I go 1 delta x, I get to x1. If I start from a, I go 2 delta x, I get to x2. If I go 3, I go to x3, 4, x4, 5, x5, and so on. So we had a formula for xi then is a plus I delta x. A plus I delta x. So that was the first step, that we are basically preparing for our estimation. Step 2 was estimate the subinterval, the area. The estimation goes like this. So we are taking subintervals, and from each subinterval we are creating a rectangle which has the base delta x, or width delta x. The height is given by f of xi. So here I denoted that by Rn, the estimation, not the area itself. R depends on how many slices we have. Also, it depends on the function and the interval AB. This is the full notation, but I may drop f and AB, sometimes AB, if there is no confusion there. And what was this? This is sum of area of ith rectangles. I goes from 1 to n. And well, we also know what are the areas of those guys. The width times the height, delta x times f at xi. I goes from 1 to n. So we found an estimation, an approximation of the area. We are getting those rectangles. But the final step, well, was when we had find area as the limit of the estimations of Rn. So in other words, we said that at the end, we are doing limit Rn that depends on f and AB as n goes to infinity. In other words, we are claiming that as you increase the number of subintervals, or equivalently, when you decrease the length of subintervals as small as possible, so you're filling out that region using so many, or as many as you can, equal width rectangles, that process, if you study in the long run or increasing trend, it will give you the area. We did an example of, what was the example? F of x equal to x squared. I did choose, I wish I choose a different interval, but I choose 0, 1. Then quickly, I'll write what we found. Delta x is b minus a, 1 over n. xi, we learned that is 0 plus I delta x, or I over n. And then we ran that our n thing, which was I goes from 1 to n of 1 over n, I over n squared. And then we did all that work, and we calculated this. So at the end of step 2, what would be useful is one expression in n. And what we found last time, I believe, was this. 2n cubed plus 3n squared plus n over 6n cubed. So we did evaluate that. We worked a little bit of work on that. And then we found that the area is limit of this Rn as n goes to infinity, which after a little bit of work here, factor out the dominant term, we got that is 1 over 3. Any questions, any comments so far? This we have done. I just quickly went over what we did on Monday, yes? Does everything look good? Easy to follow? Easy to do? Maybe? Let's do another example. Find the area under the graph of this function. F of x is 2 to the power 2x plus 3. On what interval? On the interval 0 to 1. What are you waiting for then? Go ahead. You'll get 2 minutes. We have all the components there. I'm hoping that at least you will be able to recognize the steps, the components, start working how much calculation you can do. That's something that I will try to complete, yes? Go ahead, please, 2 minutes. You're talking to a friend if you need help, or maybe affirmation, confirmation. Yes? From 0 to 1, yes, yes. Go ahead, 2 minutes started already. Since it's not loud enough, I will change the battery so that I can scream even louder. 30 seconds left. You start with the first step, simple. You're trying to set up what are the points. So I start with the length of each subinterval with the assumption that I divided the whole interval into n pieces. And that would give me b minus 0 over n, which is 1 over n. I have delta x. The reason I'm finding delta x are two things. One is that's the width of my rectangles, but to find height, I need to know what is the formula for xi. That was a plus I delta x, a log I of these things, and you get to xi. And a here is 0, I. Delta x is 1 over n, so we have I over n. Yeah? So that's step one. Now I want to start my estimation or approximation. Rn, I'll just write Rn instead of writing Rn, F, and 0, 1. I'll just write Rn here. So what is that? So this is sum of area of the ith rectangle and add up all these things. Yeah? But now I can plug in the values here. I have 1 over n. F of x1 is 2 to the power 2xi plus 3i goes from 1 to n. I'm not done yet because I have to put what is xi. But before I do that, I notice that, look, this 1 over n is a constant. I can put it outside. What I mean by constant here is that it doesn't have any variable I in it, any summation index in it. That's constant, and it's multiply. I can put it out. Also, I can write this thing as 8 times 2 to the power 2xi, because 2 to the power 2xi plus 3, it is, how about I do this? That's the same thing as 2 to the power 2xi times 2 to the power 3. Yes? And 2 to the power 3 is 8, and that's another constant. I can put it out. Here I get 2 to the power 2. xi is I over n, and I have that one. So what I've done so far is Rn is 8 over n sum 2 to the power 2i over n. I goes from 1 to n. Now we have to evaluate that. We have to evaluate it means that we have to get it sorted out so that at the end I have an expression in n only. Yes? I see this as something to the power index. Index goes from 1 to n. What was the formula for this one? Do you remember it? Say no. Do you remember it? No. Go back to your notes, Friday notes. Check that. I put 4 formulas down. I want you to review them. I know some of you know it, but I just wanted to make sure. Go back, check it, 10 seconds. 10, 9, 8, 7, 6, 5, 4. It's funny. Elon Musk counts down for what, and I'm counting down for what? Okay, the formula here is, you have to know this. R to the power upper 1 plus 1 minus R minus 1. Yes, please.
Memorize that for the all of them for the exam.
You have to memorize. I said that on Friday. I'll say it again.
The teacher in the class before you says you don't.
You have to. You have to.
So he told the class that you didn't have to.
You have to. Yes.
So, teacher.
Sorry, where's x?
2x.
So 2xi. xi for me is I over n. I over n, so we put there. Yes. Okay, here. R for me here is 2 to the power 2n. So in other words, this thing here is 2 to the power 2 over n to the power I. Okay? And the formula for this will be R to the power n plus 1 minus 2 to the power 2 over n, R minus 1. That is what we get for Rn. We are not done, but we are done with step 2. Now step 3 is find the limit of that guy. What is limit of Rn is our next step. Well, I can write it this way. So there's 8 there, 2 to the power 2n plus 1 over n minus 2 to the power 2 over n over 2 to the power 2 over n minus 1, and there's n multiplied to that. I think this is a very good limit to look into, because you guys are now, I know how to do the limits. How about I give you 40 seconds? So generous today. 40 seconds. You try to evaluate that. Don't rush through. Go step by step. What is happening in the denominator? What is happening in the numerator? And then you go ahead from there. Go ahead. 45 seconds, even more. Okay, let me look into the limit of the denominator. What is limit of the denominator? Can anyone? What is the limit of the denominator? Sir, what's it? Minus 1. Well, let's do this. As n goes to infinity, 2 over n goes to 0. Yes? 2 to the power 0 is 1. 1 minus 1 is 0. But we are not done. There's an n there. N goes to infinity. This is one of those product limits. Product indeterminate forms. Do you remember how to deal with that? I'll write x this time so that I can use, I want to do. So you turn x or f of x, the first one, to 1 over f of x. So that would give me this. The reason we are doing that is that that way we get 0 over 0 indeterminate forms, and then we can find L'Hopital. Use L'Hopital to evaluate that. Limit of the denominator, it's easy. What is limit of the numerator there? Well, that's 2 to the power u, yes? So derivative of 2 to the power u is u prime ln 2 to the power u. In this case, this is negative 2 over x squared ln 2 to the power 2 over x. I can cancel this with that. Negative sign goes away, and I do get limit x goes to infinity, 2 ln 2 to the power 2 over x. And when x goes to infinity, 2 over infinity goes to 0. 2 to the power 0 is 1, so I get 2 ln 2. That's the limit of the denominator. It's not 0. So that means that I can use quotient law here. And I know that the limit of the denominator, after doing all those work, is 2 ln 2. What about the limit of the numerator? Let's do that one now. Limit of n goes to infinity, 8 2 to the power 2 n plus 1 over n minus 2 to the power 2 over n. Oh, yeah, I will use n now. Okay. N plus 1 over n. As n goes to infinity, this goes to n plus 1 over n goes to 1. So I have 8 times 2 to the power 2 minus 2 over n goes to 0. 2 to the power 0 is, so limit of the numerator then is 3 times 8, which is 24. Isn't that fun? We use everything that we have studied from the beginning of this course. Oh, you don't like it? I see. But we use everything that we learned, like after this course started. Any questions? Any comments? If you have any questions, any comments, I can answer a few questions. Yes, please.
Where did n go over there? Where did n go?
This n, I wrote it as 1 over n. N, or f of x, is the same thing as this, yes? That's how I did that, okay? Yes, please.
Just go over it again, how you got the 2 squared minus 1 on the bottom there.
Oh, this part. The numerator, limit of the numerator, you're saying, yes? So, limit of this guy, n plus 1 over n. As n goes to infinity, it is 1. So this is 2 to the power 2 times 1, which is 2 to the power 2, minus this guy goes to 0. 2 to the power 0 is 1. 4 minus 1, yeah? Yes, you're welcome. Yes, please. Louder, louder, please. I cannot hear the questions. If you have questions, please ask me. This is the time. I think everyone else will enjoy it. Yes?
Explain the 2 to the 2 times n. And wouldn't it be infinity over infinity?
Infinity over infinity, you either do factor out the highest powers and then do the calculation, or do L'Hopital, you get 1. That's the final result. Yes, you're right. It's, to start with infinity over infinity, but then you do all those work, you get 1. Any other questions? Well, I have to show you these steps. Otherwise, you won't appreciate fundamental theorem of calculus. You won't see that if we don't have those advanced tools, doing even simplest things will take us forever. So many calculations. But on the other hand, also, you need to know how to do these kind of calculations, because even though it seems as a long process, but it's a very natural process. I'm just trying to find an estimation of area using rectangles, and then I'm finding limit. Okay? Indeed, you should be so familiar with the structure that you should be able to do the backward process. What I mean is this. Example. Identify the given limit as limit of Rn as n goes to infinity for some function f and interval a, b. What are these limits? Let me find out. This is limit of 2 over n 6i plus 1. This is over n. N goes from 1 to infinity as n goes to infinity. What is the other one? Limit of 6 over n. I goes from 1 to n, square root of 9 minus 6i over n minus 3 squared. Please write it down. I'll tell you again what do we mean by this specific example, and then we try to evaluate it. You not only need to see how to create that Rn when the function is known and the interval is known, but also going backward. Now, I am given a sum, and I want to identify this as Rn for some function and for some interval. So I have 3 things to fix. What is A? What is B? What is F? Okay? And what we are looking for is that I want to see this, find a pattern for which I have something like that. Would you like to start doing one of them at least? 1 minute. I know it will take a little bit of time, but I want you to engage in this problem yourself. Try to see. finding pattern. It's not about anything else. It's just finding pattern. How about don't do calculations? Talk to your friends. Talk to your friends. I want to hear some chat. And you're trying to see what components you're seeing already there. And if you can, find out what are the function, which part is delta x, which part is f of xi. Go ahead, I want to hear some chat. Yes. Yes.
Limit, is this I in the question equals 1?
That's I from 1 to n, yes. I am, well, change this one, sorry. I made a mistake writing that way. This is from, I goes from 1 to n. The same thing should be there, yes. You get your 1 minute back now. Yes. This is pattern matching, basically, yeah? Okay. There are two pieces into this sigma. Delta x, f of xi. You know how delta x is. Delta x is going to be a number, which is b minus a over n. Yes? A number over n. Doesn't that sound like it? Yes? It's a number over n. So I can say that, okay, maybe this is the pattern that I found. Delta x is this piece. The rest is f of xi. Yeah? And let's see what we can get from those two things. Delta x is 2 over n, meaning that b minus a over n is equal to 2 over n. Yes? And that means that b minus a is equal to 2. Okay? I haven't yet been able to find what is a or b, but I know that their difference must be 2. Now, if you're in this situation, you have a freedom to pick a to be any number you like. The simplest thing that will help you with identifying other parts is when a is equal to 0, then b will be 2. And yes, we have a choice to make there. We can choose a to be any number you like. But when you choose a to be 0, it will be the simplest thing in identifying other parts. Not necessarily calculations. Yes?
It's not more simple to look at f of xi and then say a is 1?
I wish I had the time and go all the way to the end of what you claimed. And then I'll show you that there's something not right there. Yes. Try that. If you take a equal to 1, then that would be a bit different than that. So it will need a little bit of work from you, yes? But that's a good mistake to make, let me tell you this. I wish I had time and I would go through that all the way, yeah. Okay, then the other part, okay, by knowing this, then I know what is xi. Xi is going to be 0 plus I delta x. But delta x is 2 over n, which is 2i over n, yes? So I found what is xi. And now f of xi, I'm claiming is equal to 6I over n plus 1. Or in other words, I'm claiming, I'm claiming that f of 2I over n is 6I over n plus 1. Can you see what would be f of x in this case? If f of 2I over n is 6I over n plus 1, what would be f of x then? If my function is 3x plus 1, meaning that if this is 3 times 2I over n plus 1, then I'll get this one right. Yes? So that is what we were looking for. F of x is 3x. That is A, that is F, that is A, that is B. That is F, 3x plus 1. A, we set it equal to 0. B, we calculated must be equal to 2. Yes, please. There is a choice to make there. Yes? And you will learn later on why you have that choice. You can choose any different thing there, but calculationally, finding f of x, that would be easiest if you put a equal to 0. Just figuring out the pattern, that would give us the simplest case. And the answer back to your question is, I will suggest always put a equal to 0. Yes, in these questions like this. Yeah. Any other questions? Any other comments? Should we do the other one maybe? Yes, yes, please. So I know that my function works this way, that when I plug in 2I over n, I'll get 6I over n plus 1. I want to write this 6I over n plus 1 in terms of 2I over n plus 2I over n. And I see that if I multiply 2I over n by 3, I get 6I over n plus 1. Yes? So in other words, what we figured out here that I plugged in box here, it spit out 3 bucks plus 1. That's the other way of writing that. Yeah. Any other questions? Any other comments? Would you like to do the other one? Would you like to do the other one? Yes, I like that. Who said no? Okay, go ahead, please. You have 90 seconds to identify what would be the interval AB and what would be the function f of x in this case. Go ahead, please. Okay. That's one way of identifying. Would that be the correct one, good one? That's a different story. I'm trying to just check and match different pieces there, yes? So if this is true, then delta x is 6 over n, which means b minus a over n is 6 over n, which means b minus a is 6. set A equal to 0. So A equal to 0 will give me B is equal to 6. From that, I get xi is 0 plus I times delta x, which is I times 6 over n, or 6I over n. Yeah? Why do I need that? Because I look at this piece. I look at this piece and say that, okay, if my xi is 6I over n, then what I have here is basically 9 minus xi minus 3 squared. Yeah? If 6I over n is xi, then that's what I have. Well, we have the formula already. F of x is 9 minus x minus 3 squared. That's it. Do we all have it in some ways? Yes? Maybe more practice. Well, this pattern identifying is very important, especially when we learn more about definite integrals. This will come back in some ways for us. Well, now the question is this. If someone wants to evaluate this limit, if someone wants to evaluate the first limit, limit of I goes from 1 to n, was it 2 over n, 6I over n minus, or plus 1? Plus 1. N goes to infinity. Can you evaluate that limit? Can you evaluate that limit? Well, you say that, okay, I can take out this piece. There is I there. I can split things up. And then I can evaluate each term and then find the limit. Yes? This is possible for you. You should be able to evaluate that completely. But now seeing that this is equal to limit of an Rn, I know that this is nothing but area of the region under f of x, 3x plus 1, on the interval 0 to 2. Yes, I know that one. Isn't that easy? Can you find that area without doing all those work, limit thing? What kind of area you can find under that graph? 30 seconds, work with your friend, try to see if you can do the area of this thing without going through those painful summations. Go ahead, do it now. Did anyone find that area for me? Yes? No. Someone said yes? Oh, thank you. Can you tell us how did you find it? Oh, you want to show? Oh, wait. Okay, let us go through this quickly. 3x plus 1. This is y equal to 3x plus 1. In this specific case, the region under the graph of this function is one of those trapezoids. And this part is f at 2, which is 6 plus 1, 7. This part is f at 0, which is 1. Yes? And that area is equal to half of this plus that, 7 plus 1 times 2. Okay? And that is 8. So this limit, by knowing that this is limit of some Rn, I can do it because I know how to evaluate that. Find that region, or find the area of that region. For the second example, now, interesting thing about the second example is this. The second example you have there, evaluating this summation is not something that you can do. With your knowledge, I don't think I can do it neither. Like, there is the formula for square root of that thing. I cannot do it. I don't have a right way to evaluate. But now, I know that this is the area under the graph of this guy. What kind of graph this function has? Y equal to 9 minus x minus 3 squared. What kind of graph does one? Yes? No, I want to have a shape name. What kind of graph does it have? Yes? So what? Parabola. Parabola is when you have x to the power 2 plus some other smaller term. But here we have a square root. Let me write this one another form. I heard something. I heard something. What was it? Yeah? Circle. It is x minus 3 squared plus y squared equals to 9. What kind of circle is that? It's a circle of radius 3 centered at 3 and 0. This is 3. Why it is semicircle? Because my y here must be positive, so I only taking half of it. You know how to evaluate the area of that? That is pi r squared over 2. It's 9 pi over 2. This summation, this limit, without that technique, is not possible to do. But since we know it is limit of Rn of some function, and we know what is the area there, I can evaluate. Have a great day. See you all tomorrow.
Sir, I'm so sorry to bother you, but okay, so
Let me.